Assalamu alaikum. Today we will complete our studying for halogenoalkane reactions, and in last video we studied reaction with ammonia, and we said about we talk about the reaction conditions, how it should be. One of the main points, it should be in sealed tube, okay, to have two things, or to make sure there's two things will happen. The first one, we can increase the pressure inside the reaction tube, so this will make the reaction faster and to prevent ammonia from escape. Our today important point, and when halogenoalkane react with ammonia, amine will form and hydrogen halide. Hydrogen halide, like hydrogen chloride, hydrogen bromide, hydrogen iodide. Yes, I know the common name, it's hydrochloric acid or hydrobromic acid. This is the solution of these compounds. Hydrogen chloride, it's gas, okay? When it dissolves in water, it will be hydrochloric acid. Now, we have acid and base, both at the same place. So what will happen? The products are acid and base. The products are acid and base, so when they form, they will react to give another product. What will happen? RNH2, my amine, will react with hydrogen iodide to give me this product and these ions. So we can write the chemical equation as, we can't write it in this shape, okay? It should be something like this. This is my reaction actually. Halogenoalkane with ammonia, it will give me a completely different product. It's not amine, okay? It's a positive cation and a negative halide, okay? Now I lost my amine, I waste my product. So to avoid this change in product to happen, we use excess ammonia. Why excess ammonia? Why we use excess ammonia? We talk about this ammonia, it should be in excess, okay? When start the reaction, so what will happen? When the acid form, when we add excess ammonia, okay, we will give amine. Why? What will happen? What's the main change will happen when we add excess ammonia? How it will react with this product to give me amine again? That's what will happen. When ammonia, the excess ammonia is, when the first ammonia molecule react, it will attack the partially positive charged carbon, which is bonded to halogen, okay, and it will give me this structure, okay. What is the positive charge? It's at nitrogen, because the nitrogen will donate these two electrons, and the negative halide, it will react again to give this product. But now, if there is no excess ammonia, if we don't have this step, what will happen? This negative halide, it will bond it to this structure to give me this product, okay? But what will happen? Now, at this moment, the excess ammonia with these two electrons will react to take one of the hydrogens from this positive ion, and the two electrons will come again to nitrogen to give me this structure, which is amine, okay, and NH4. Now this NH4, it will attract with the halogen halide here to form this product and keep my amine safe, okay? So here in this experiment, I want from you to take care from the base acidic product and basic product, basic product, and how we can prevent them from reacting together by adding excess ammonia, which will react or change the mechanism of the reaction. So keep amine as my main organic product. keep amine my main organic product. Now elimination reaction. Elimination reaction, we talk about this when we talk about potassium hydroxide reaction. Now when potassium hydroxide reacts with halogenoalkane, if the solvent is alcohol, and we are especially talk about ethanol, okay, what will happen? There is no water, not water, my product, my solvent's not water, it's called ethanolic potassium hydroxide or alcoholic potassium hydroxide. Okay, the reaction will change from substitution to elimination. Now what's the elimination? This halide were removed with one of the hydrogens, okay, to give me double bond, okay. Now the mechanism, it's not my point now. We need to know, in potassium will react with X, okay, to give me Kx, let's say, and it's Br here, and this hydroxide will remove one of the hydrogens to give me alkene. So it will convert halogenoalkane to alkene if it is ethanolic. If it is ethanolic potassium hydroxide. In this reaction, hydroxyl group will not act as a nucleophile. It will act as a base. One of the main differences between the two reactions, hydroxyl group act here as a base, not as a nucleophile like in substitution reaction, and it will attack the hydrogen atom. For this reason we have H2O. It does not attack the carbon, okay? Doesn't attack the carbon because these carbon carry a partially positive charge, but it's not attacked by the hydroxyl group, okay? And the hydrogen atom attack the hydrogen atom, okay, which is at the next carbon, okay. And the mechanism is not required in AS, but I will tell you some points about this mechanism, okay. If two carbons bonded to carbon which bonded to halogen, if they are identical, two products will form. If they are not identical, two products will form. Here the carbon which is bonded to halogen, it's divide the molecule to symmetrical part. We have this part is symmetrically identical with this part, so we will have one product. If you remove this hydrogen or this hydrogen, it will be the same. But what will happen if we have different molecules? Like here, what we have here, this is the carbon which is bonded to halogen. If you look to the left side, it's not identical with the right side. The left side is not identical to the left side. So we will get two products. We will remove the hydrogen from this one with X from this carbon, or from this one with X from this carbon. Let's see the products. Now, if we remove the hydrogen from this carbon, which is at the left side, okay, I label the products with the same color of reactant, okay. What will happen? The double bond will be at the second carbon, so it will be hexene, hex2ene, 1, 2, 3, 4, 5, 6, hex2ene. If we remove this halogen and the hydrogen from the second carbon, while if we remove the halogen from this carbon and the hydrogen from the other side, my product will be hex3ene. They are not the same. So if the two sides around the halogen not identical, I will get two products. Okay, and this is what you see here. Here we have no majority. Okay, why? Because if you recall your cis-trans isomers or EZ, you will find this one have two branches, and this one have two branches, this one have two branches, methyl and hydrogen, and here hydrogen and propyl, while here ethyl and hydrogen, and here ethyl and hydrogen. Both have the same number of branches. We are not talking about size here, we are talking about number of branches, so they have the same stability and the same majority, okay. The mechanism will not support any of the two products, both have the same stability. Now, what will happen if two products will form? how we can have a major. I mentioned a major, no major. That means in some cases it may be one of the products major. Yes, let's go to this one. Now here we have this compound X and the halogen here. This part is not identical with this part, so two products will form. Let's start with the first product. I will remove the hydrogen from this side. It gives me this product. Okay, double bond between the first and second one. If you look here, we have no branches. There is no branches here, only hydrogen. Okay, now let's go to the other product. I will remove the hydrogen from this side, so the double bond will be between the second and third one, Here we have hydrogen as a branch, and here, methyl as a branch, and here we have methyl as a branch. Remember, in this compound it says CH3H, CH3H. So it can be cis and trans. While this one, it's CH, H, double bond, C, H, and C2, H5. There is no cis trans. More branch, more stable alkene. It's one of our rules. More branches, that means more stable alkene. Here we have only one branch. Here we have two branches. So this one more stable, so it will be the major. Keep it in your mind, okay? The product which contains more stable or can give us cis trans isomers, it will be the major one, okay? More branched alkene will be the major product. Explanation again not required in our syllabus for this year. And after that we'll study our new topic, which is alcohol reactions, some alcohol reactions. Now I want from you to recall naming of alcohols, structure of alcohols, and types of alcohols or classifying of alcohols. Till next time, see you. Assalamu alaikum wa rahmatullah.